Well, good morning. As the example of accelerated motion, we look at the free fall motion or projectile. So it's things like this in any balls. And now falling motion, free projectiles, and basically for anything, speed of is not dependent on the weight of an object if you ignore the air resistance. If you have a small coin or a big ball, it will fall at the same acceleration. So here are some videos have very interesting experiment where they put feather and coins and same in the vacuum and drop. You can see that the feather drop as fast as the coin. So, and then in the downward direction, it will go like this formula we talked about. We have many examples, but this one is accelerating downward or free fall, and with this 9.8 meter per second squared. So it followed by this formula. Normally, it moves like this nice parabola curve, but we can separate the motion in two directions. Basically, we split between vertical direction and a horizontal direction. In vertical direction, it's been accelerated constantly by g. So, which means the two directions are symmetric. When going upward, and it's constantly deaccelerating at the top, and still have the acceleration. It goes down. However, along the horizontal direction, it is simply a steady, constant motion, constant velocity. In other words, if you combine this vertical direction and horizontal direction together, you can see that in this direction, velocity never changes. While in this direction, you see small and bigger and big and big and big. But whatever you throw with, and then the vertical direction, it will be falling as if it was a free fall, like this. In other words, if you try two objects, one you go through horizontally, and the other one simply free drop, they will drop to the ground at the same time, even though that one land farther away, this one a lot just next to the wall, and then these two, the horizontal, how far we will land depends on the horizontal direction velocity. Basically, it's a constant. How far we will drop, it depends on gravitation.